So welcome to part 2 of dozer repairs and maintenance. We'll turn our attention to a couple items on the blade. Took some doing. It's rather warm. Well, the other ones will be just like it, so I won't bore you with that. So I'm guessing this edge was straight, so it looks like there was a little bit of wear, perhaps before they sort of end-for-ended the bits. They let this one wear down a bit too much. This is just some old wire rope grease. It's really nasty. I thought this was a good place to use it because it'll never be touched again, at least for quite a while. And it is thick and gooey. I think I probably bought this, I'm not kidding, like 30 years ago. I don't even know if they make it anymore. It's like tar, except it never hardens. It's always a liquid. Well, I could use the torque wrench function of this thing. Which is 300 foot-pounds. Take that back, that was Newton meters. 250 foot-pounds. So not that far off. So I won't bore you with me picking up. Gonna put the sides on. This is too good a metal to just throw in scrap. It may find use someday. So we're pretty much done with what I wanted to do. You can see the wear. There's a bit of wear down here. So it'll be interesting to see a line in whenever I back drag. But I have at least probably 1.25 inches of wear here. There's no sense replacing these. Quite a bit of difference in thickness. Because these, the bolt heads are recessed, and these are all worn off. So not only do they wear this way, they also wear obviously quite a bit in thickness. We'll see. I don't know if that gap is. Guess I didn't expect that much of a gap. It's like over 1/4. It's probably 3/8 of an inch. Anyhow, before I was interrupted with myself, I do have, there's another sideshow. Gosh darn it. So some areas here that I want to patch, probably with some 1/4 inch plate. Granted, it probably could use a new skin, but I think we're a little bit away from that. But I would like to at least prevent these from getting dirt and crap behind it and bending, and that's really thin. So I can probably put a patch there, but I might need to buy some 1/4 inch flat to make a piece big enough. So obviously I want to patch this area here where it's very thin and the skin has started to separate from the frame. So I cut these at a little bit of an angle like that so that I could weld to the beef. There's obviously a frame support here and at the bottom here, so that's where I want to weld it to rather than having it straight, which would sort of be at an angle to the blade. But now I need to try to bend this to match somewhat the contour of the blade. I'm going to try to just do that in the vise without using heat if I can. contour fits fairly well. It's a little bit rocky this way. So what I think I'll do is weld the top and this, basically this corner. And I think I can fasten a C-clamp or something around here to bring this tight to it. I might have to heat it up there to make it bend. Had I been thinking, which sometimes I fail to think, I would have done it before I put these on. Would have made easier access to this bottom, but even if, yeah, I have to weld the bottom. I don't want anything to go underneath there. Because I really wanted to keep this down here. So I needed the vice grips there because this kept sliding down. So I tightened it. Still not quite as tight as I'd like it. I'd have better luck with it. It's fine thread, so that should give me more mechanical advantage. Oh yeah, should have used the right tool to begin with. I'm going to do this inside corner, then see if I can't do this, bring this a little bit tighter here on this corner. Oh, such a much better tool than whatever this is called. Oh, this thing came off. So this side turned out okay. It's a mix of 6011 and 7018. One, because 6011 is kind of easier. And I wanted it to penetrate particularly on this side. So this is 2 passes of 6011. Most of this is 7018. Then the bottom is 6011. This is 2 passes of 7018. The other reason I wanted to use both is because I'm running out of 7018. I only have 3 more, and I still have 1 more side to do. So I'll do all the root passes with the 6011, and then just the wear side, which would be this side primarily. I'm thinking they'll see the most wear with the 7018, which I think is a bit more abrasion resistant than 6011, at least by a little bit. Anyhow, easy enough to re-weld if they look like they're wearing out. So let's move on to mounting this other side. This is not a big issue if I can't close this gap up a little bit. Okay, either way. So that one's done. Makes both of them. It's kind of nice. It sort of looks symmetrical. Maybe not like it belongs there, but it doesn't look odd. It's not like a patch up here in the middle of nowhere. So let me show you something else that happened when I was bending this just after I had turned the camera off. When I was bending the last piece, I cracked the vise right there all the way through to that side, so that whole thing is cracked. So I was able to finish it up using this end of the vise, which I've never used before. It's made for pipes and other odd shapes. So this was the Irwin, which I thought was a decent brand name. Maybe I just overworked it. It's only like a, I guess it's a 4-inch. Five-inch vise. It's only mounted to this wood, and every time I move it real hard, I can sort of feel the wall of my garage move as well. So what I might do is maybe get a 6-inch vise, get a little bit bigger one, and then maybe or try to weld this up. I've never welded cast before. This would be a nice experiment. Take this thing out, heat it up, I guess. I don't know if you can use a regular rod or you need a special cast iron rod, but I'll figure that out. Look at that. So this vise, I looked it up, not necessarily an Irwin, but there seem to be several brands that have identical designs, so I'm guessing they're all made by the same folks. I was about $130 to $140 for a 5-inch. I could go to a 6-inch for $170, I think. And if I can't repair this one, that's what I'm going to do, because this vise is kind of important to me. I use it quite a bit. So the crack is here on the other side. I've never welded cast iron before, so I'm going to give it a try. They make special rods for it. There's 3, I think, that Hobart makes. This was the cheapest, and it says for various grades of cast iron. So I'm going to give it a whirl to try to repair it. If it doesn't work, then this goes for scrap metal, and I'll get another one, unfortunately. So the first thing I want to do is remove the paint and make a little bit of a groove. I have plenty of room here, so I'm not worried about necessarily trying to maintain the original shape. So I'm going to take this tool here on my die grinder. There's several shapes. I just picked one that seemed to be the most appropriate. I'll gouge this out a little bit, remove the paint around it, I thought of taking it off and bringing this outside, but I do have a fiberglass mat made for welding, so I thought I'd just try to do it here in place. Hopefully that works. If it doesn't, I do have a fire extinguisher over there somewhere. Oh yeah, right there, that red thing. So let's grind this out. So the electrode says positive polarity is preferred. So I switched to positive. Normally you run negative polarity or reverse polarity. It didn't, this particular rod did not say anything about preheating, but I think that's a good idea for cast iron. Some of the other, like a nickel iron or a pure nickel rod, it says preheating is mandatory, like 600 degrees. So I'm going to preheat this a little bit. I'm not going to go crazy, but it should help out. That welded pretty nicely. That's the real test. Will be putting it under pressure, but I'll put a couple more passes on it. So this last pass I'll do it, I think they call a cover pass. We'll see how it reacts to it. It's just sort of a sweep across the entire area. Oh, this over here looks fine. There, it doesn't look like it penetrated quite as much. The other side. So this side's clamped and heated. I did add a bit more heat to this area, which is a bit meatier. So maybe that's helps explain why my penetration wasn't good on that side. Didn't seem to be quite as good on that side. Maybe it didn't get heated as much. So there she be. I think it looks okay. It's certainly not pretty, but hopefully it's functional. It does. I think one of the other things with cast iron welding is to let it cool down slowly. Not that I have much control over it. I guess I could put a rag or something over it to help it cool down more slowly. Let me just put a couple gloves on. So one of the selling features for this particular rod was economical. This I think is a 1 pound, 1 pound package. It costs $30, like on Amazon and even at Tractor Supply, to get the 100% nickel or the nickel iron alloy was like $15 for literally 5 rods. Or I think a pound might have been $50 or $60. Anyhow, these are not cheap, but if you break cast iron, I guess they can come in very handy, assuming this weld actually holds up. So my oil sample results came back, so I'm going to review those. But one thing I want to do first is correct something I said in part 1 of this dozer maintenance video, which was incorrect. That has to do with the steering pedals and how that works, particularly the clutch. What I mentioned on that video was that when you press the clutch, you're disengaging, or press on the steering pedal, you disengage the clutch first, which is correct. But I said you operate a master cylinder, and that in turn operates a slave cylinder, which disengages the clutch, and that's not correct. That's how most modern manual transmission clutches work, and it takes a fair amount of effort to, you can feel that you're actually pushing something mechanical. But after I realized how this actually operates, it makes sense, because the steering pedals actually push quite easily. So instead of a master cylinder, what you're pushing is actually a hydraulic valve. And that valve directs oil from the pump in the transmission to the slave cylinder in the clutches, and that disengages the clutch. So the basic operation is the same, except that hydraulic thing that you first press with the steering clutch pedal, the steering pedals, is a hydraulic control valve. It is not a master cylinder. So this is my Blackstone website. I have an account there, so you can just log on. But these are the ones that I just got in, so I'm just going to go through the results. I've opened them all up. I'm not going to go through all of them. There are 8 of them here. So we'll look at the first one. You can pause this and read this if you'd like. But this is the actual engine. So they basically the engine oil was okay. There are some things that were high. The iron is a little high. You can see this is bold. This is what I got versus what the universal averages are. Aluminum's a little bit high. Silicon is a concern regarding, because really the only time you can get silicon in lubricating oil is from contamination from dirt or the air. So what they'll mention up here in the paragraph is look at your air filter housing. Are there any leaks? Is there any way that dust or dirt can be getting into your engine? And then they talk about the viscosity here. This one is the differential, or the bevel gear, and this one is in good shape. So there are 2 that were in good shape. This one and the hydraulic, which are in good shape, and I'm not going to change them because the oil analysis says that I don't need to change them. So it's a good report for this bevel gear. Oil was in good physical shape at the time of sampling too. No moisture was found. So I'm not going to change the bevel gear oil. Final drives, the left and the right side were identical. They said front here, I think they meant the other side. Wear metals, silicon were elevated, not as high as the other differential, not the front. I'm guessing they must have been left side or something. They talked about if it's the first one, this could just be break-in, but the aluminum is high, the copper is high, silicon is high, so again, there's some contamination somehow, and the viscosity was fine. This one is the left clutch and brake. This one was very high. You can see iron, 1255. This is parts per million. All these were in parts per million versus an average of 2, a universal average. Silicon was again high versus a 3. So, and that's really what I'm faced with. This was the hydraulic system. So the hydraulic system says very little metal was present. Viscosity was in the 10W to 20W range. 10W is what I would replace it with. I will replace the filter, but I'm not going to replace the oil. And this was the transmission. This is the last one that I got. So this was sort of borderline. It says it's wearing well, metals at or below the universal averages. So, but I have the oil. I might as well change it. and it's not that difficult. So I'll change that, so I'll have a lot of the gear cases sort of at a new change interval. I'll document the hours, and then I'll have samples done again later. So we'll get these oils changed and they'll be ready to go. So with the oil samples complete, the only thing I haven't changed yet is the transmission oil, and I'm going to change the two filters, the transmission filter as well as the hydraulic filter. Then it'll be ready to go. So that'll wrap it up for sort of the initial servicing of the dozer, which is new to me. So thanks for watching. I hope to see you soon with this dozer at work. Appreciate it. Bye-bye.